This video covers required practical 2, which asks you to determine the concentration of an acid using a known volume and concentration of an alkali. We'll look at the method for the practical, a summary of the method, which you could write if you were answering an exam question, and then look at some example data and the calculations you would do with the results of your practical. You would set up this practical by clamping the burette vertically in the clamp stand and closing the burette tap. You'd place a white tile underneath the burette. The first step of the method is to use the funnel to fill the burette with hydrochloric acid. You would then place a 100 cm³ beaker underneath the tap, gently open it to allow the acid to fill the tap, remove the funnel and record the starting volume. Use the pipette and pipette filler to put exactly 25 cm³ of sodium hydroxide into the conical flask. Put 5 drops of phenolphthalein indicator into the conical flask, swirl the flask to mix and put under the burette on top of the tile. The contents of the flask will go pink. Carefully open the burette tap so that 12 cm³ of the acid slowly flows into the flask. Constantly swirl the flask when adding the acid. Add the acid drop by drop until you see a permanent colour change from pink to colourless in the flask. Read the burette scale carefully and record the volume of acid you added to 2 decimal places. Repeat these steps twice more and record the results. We'll now look at a summary of the method you could write if you were answering an exam question on what the method for this practical was. The first step is to measure the volume of alkali accurately using a pipette and filler. You would then add an indicator to the alkali, swirl to mix and place on a white tile. You would then fill a burette with the acid, and note the starting volume of the burette. You would then add the acid. You would add the acid dropwise near the end point while continuing to swirl the solution. Once you've reached the end point, you would read the final volume of the burette. Repeat all of these steps twice more and take an average of the readings. We're now going to look at some example data from a practical and look at how we could analyse it. The first test had a start volume of 2 and an end of 18.5. The second, a starting volume of 18.5 and an end volume of 35.3. And the final test, a start volume of 20 and an end volume of 36. We now need to work out the volume added by doing the end volume subtracted to the start volume. So the volume for trial 1 would be 16.5, the volume for trial 2 would be 16.8, and the volume for trial 3 would be 16.6. Question 2 asks us to calculate an average of the volumes added. To calculate an average, we would add together all 3 of the volumes added and divide by 3 as we have done 3 tests. This gives an answer of an average volume of 16.6 cm³. Question 3 says 0.1 moles per decimeter cubed of sodium hydroxide solution was used in this investigation. Calculate the moles of sodium hydroxide used. The first step will be to write out our equation linking moles, concentration and volume, which is moles equals concentration times volume. We would then sub in the values from the question, so we would do the moles of sodium hydroxide equals 0.1 moles per decimetre cubed, which were given in the question, times 25 centimetres cubed divided by 1000. We used 25 centimetres cubed of sodium hydroxide in the method, and we would divide it by 1000 to convert the units from centimetres cubed to decimetres cubed. This would give us an answer of 0.0025 moles. Question 4 says using the average volume of hydrochloric acid added, calculate its concentration. We would start by writing a balanced equation for this reaction, noting that the acid and alkali are in a 1-to-1 ratio, so 1 mole of acid reacts with 1 mole of alkali. We would write out our equation linking moles, concentration and volume, so moles equals concentration times volume, and rearrange that to find the concentration, which would be concentration equals moles divided by volume. We would then sub in the values into this equation. So the moles is 0.0025. We know the moles of sodium hydroxide was 0.0025. We've got a 1-to-1 ratio between the moles of acid and alkali. Therefore, we must have 0.0025 moles of hydrochloric acid. The average volume we worked out in question 2, which was 16.6, and we've divided it by 1000 to convert centimetres cubed into decimetres cubed. This gives us an answer of 0.15 moles per decimetre cubed.